I'll do a quick introductional. My name is Mary Senosiain. I'm the product manager for Stratasys Direct. I've been in the additive industry for almost over 8 years. I started as an entrepreneur with my own service bureau. Luckily, I now have access to a lot more technologies as part of Stratasys Direct. So Stratasys Direct is Stratasys Service Bureau here in North America. And so I help oversee and manage the roadmap for the customer experience across all 9 technologies that we have.
Awesome.
Barbara, who is joining us, is actually an additive and manufacturing professional with over 30 years of experience. So I'm going to refer to my notes here. Barbara brings a really diverse background to the table. She's championed 3D printing as well as plastic processing, tooling, and other supporting technologies that are very well known. She's published over 70 papers, has won numerous awards, has held quite multiple roles in several organizations, including the Society of Plastic Engineers, SME and Women in Manufacturing, and the Society of Women in Engineers. So her past career actually includes sales, operations management, to be clear, project leadership for many of the injection molders, thermoforming, rotational molding, resins, mold making, tool and die, as well as her experience in specialties in rapid tooling, including stereolithography, SLS, FDM, polyjet, multi-jet fusion, SLM, and high-speed machining. So welcome, Barbara. Joelle is actually joining us from Stanley Black & Decker. She is the Business Development Director. Congratulations, Joelle.
Thank you.
And she is concentrating on operation innovation within manufacturing. And her goal is to continuously bring innovation into manufacturing and increase productivity and ultimately grow the bottom line. Joelle is currently leading a major initiative to bring additive manufacturing capabilities to each of the Stanley Black & Decker locations. So that's over 400 facilities across the world, right?
Mm-hmm.
And she actually began her career in manufacturing, learning the ins and outs of how a facility operates as a manufacturing engineer at Tiffany & Company. So it's very, very unique and very cool in my opinion. And then she later specialized in additive manufacturing and is focusing on how enterprise companies can benefit from leveraging this evolving technology. And Joelle received her BS in Industrial and Systems Engineering from the University of Rhode Island and is also a Lean Six Sigma Black Belt. So welcome.
Thanks, Mary.
Well, it's a pleasure to have you ladies. We're not to say guys. So Joelle, I'm going to start with you. What got you started in additive manufacturing at Tiffany's?
Yeah, absolutely. So like you mentioned, I started out at Tiffany as a manufacturing engineer, so learning about their current processes. They were utilizing additive very early on for lost wax casting and investment casting. So actually printing wax models. And so there was an opportunity that arose to participate in some R&D for additive, see where else we could leverage it. And at that point in my career, I was really looking to be more involved in the business decisions and looking to explore more technologies. So I jumped at the opportunity, and I kind of, it was a happy accident that it turned out to be additive manufacturing because I previously didn't have much experience in it. But that's where my path has led me, and I've been working within additive now since that point. So I clearly like something about it. I love the additive community. I think events like these are great, and there's so many people that have, like Barbara, a lot of different experience, where I would say I'm more so in my infancy with my time within the industry, but I really like it. So that's kind of how I got started.
What about you, Barbara?
I came from an industry that was very, very different. I came from the medical field. So I have actually a degree in biology and clinical medicine. And when I discovered a couple of things that are reality based in that about me, you can't make any money being a bench biologist. So doing Petri plates means that you're very poor all the time. And I had worked my way through college being a tool and die apprentice slash machinist to my father. And so I loved making things that with the ability to go into the plastics industry, because at that time there wasn't any tracks to learn plastic engineering. I was able to enter the world of plastics and get a lot of great experience. An opportunity to join an additive manufacturing company came up quite a while ago. And these guys took me under the wing. They taught me not only about what they had at that time, which was mostly stereolithography and SLS, but also the history of it. And I could see where I'd worked in the industry inadvertently before. I'd actually run a LOM machine, a laminated object manufacturing machine, very, very early on in my manufacturing career. So I somewhat fell into it, but then it was, you might say, a controlled fall because once I was there, I never wanted to leave. And I still love the industry. I love the tech. In fact, anyone that knows me will tell you I am absolutely a 3D printing geek. I love doing it. I love talking about it. I carry sample parts with me. I believe it can benefit every type of manufacturing. A key for me is to make sure that we know that it's not a fit everywhere, but it has an impact everywhere. So for those of us in the manufacturing world, you have to be selective. But in the old thing from Glenn Beal in the plastics world is that just because you can doesn't mean you should, but you should try in most cases. So that's how I ended up in 3D printing. I've gone through all the technologies. I've worked for major corporations as well as startups. Love the industry and so happy to be here and with a distinguished panel too. Wow. So it's exciting times. It's great times. And it's a great time to be a part of women in 3D manufacturing.
Yeah, I mean, I agree with everything you just said, Barbara and Joel. And this day as well as tomorrow is going to be quite inspiring to uh, everyone involved. I haven't heard anyone say otherwise.
Yeah.
So let's go ahead and deep dive a little bit into production. You both have experience introducing additive to production life cycles. So right off the bat, in your experience, what has changed once you've implemented additive into the production life cycle? We'll get back to prototyping and that detail in a little bit. What's the first impact right off the gate that you guys have seen? So, Joelle, we'll start with you.
Sure. I think one of the biggest impacts of leveraging additive in production is the buy-in from the organization that it's being implemented in. So I've historically and still work with large enterprise companies to implement additive in. And I think one of the biggest hurdles is getting everyone on board with this is a great solution. These are all of the benefits from it. It's going to work. So I think right from the start, once you put a part into additive production, it starts changing the way people view additive as a solution. And I think it really drives adoption when a large group of people can see the impact and, wow, it really can work. And I can't believe they're doing it. How do I utilize it? How do I create new products for it? And I think that's been the single most important driver and impact from bringing additive to a production level, is that education and just opening people's eyes to the possibility.
What about you, Barbara? Coming from conventional manufacturing and then putting an additive into the production life cycle, what did you see change or improve?
I totally agree with everything that has been said previously because it's an education process and we are on that journey, but we're not at a finish line yet. Mass adoption of additive manufacturing or 3D printing or whatever you're calling it at the time, which I tend to include rapid machining technologies in there too, besides just what we refer to as 3D printing, it still has had an impact in ways that really go back to the concept of what the part does. Instead of just thinking about conventional manufacturing and how we put parts in front of our customers, we're now actually looking at the art portion of the art to part to production and saying, what is this supposed to do? And then going back and designing for additive manufacturing to be put into production. And various technologies are better fits than others when you go into production. I think that's a key to talk to the manufacturer, especially traditional manufacturers that may not be aware of all the technologies. SLS parts, there are a huge difference from SLA parts and vice versa. Multi-jet fusion versus FDM. There's a lot of differences on the strengths and relative fit of those technologies. But the thing I still see now that we're talking DFAM, design for additive manufacturing, that we're actually differentiating it down to design for additive manufacturing within the industry segments into specific technologies. You design somewhat differently for a filament-based additive manufacturing solution than you would for a powder-based manufacturing solution. So we're starting to get that differentiation on the technology. And we also are looking at when additive doesn't fit as a part of the overall solution we're offering. The best innovation is often not a huge lift. It is a hybrid of innovation, new technologies, and traditional manufacturing. And we're starting to see more integration of that. That is huge because now they're seeing it as an option. And sometimes things are, oh, I can do that portion of it in additive. I still need to do this portion, for example, in injection molding. So we're seeing a blending of those technologies, those positionings, and those concepts. That's huge.
So let me ask you this. You guys can pick who starts. Barbara, you mentioned the different terms that we use in the industry today, but you mentioned two in particular, 3D printing and additive manufacturing.
Yep.
There's a very clear difference. I think we agreed for those who have been involved in production. But where is the tipping point?
It depends. I've got it tattooed across my forehead. It depends. There's so many factors that go into when it's more economically feasible to do additive manufacturing versus 3D printing. Now, 3D printing, all of us love 3D printing, but sometimes we look at volume constraints as well as 5 major factors that determine whether or not the part itself is being used as a production method versus a prototyping method. A lot of times it's volume-based, it's cost-based, it's cosmetic-based, it's material characteristics combined with the technology to do certain things to the part. And one of the other ones is just the speed. How fast can you get it, depending on your volume? And all those things kind of mash together to give you a good solution. So the tipping point between additive and quote unquote 3D printing, it's constantly moving a little bit. And I think it's hard to put a line in the sand where, oh, it's now additive versus, oh, it's 3D printing. And you shouldn't say only 3D printing, but it's 3D printing. That line's constantly getting blurred. That line's constantly moving. All of us have worked with craft machines, as I call them. Those are the desktop printers that usually are fairly inexpensive. That's a great introduction to the technology. We all love them. We almost all have them. And thank you for reducing those prices of those so I can have more than one. Thank you. But when you get into doing mass production, and it's different for injection molding versus additive. Injection molding, 5,000 pieces is nothing. But you go to additive manufacturing, 5,000 pieces is a pretty good batch. So you have to define it with your customers on what is additive versus 3D printing. And it's kind of a long-winded answer, but I don't think you can define it. It is defined by the needs of the client, the technology, the materials, and the part itself.
What about you, Joelle?
Sure. I think I have a different view than Barbara. I agree that there's like a blurred line for sure between 3D printing and additive. But working with colleagues that don't generally think about additive manufacturing all day, every day, what I've seen is when we say additive manufacturing to them as a solution, they have no idea what we're talking about. So I almost use those two terms interchangeably because there's a better understanding of 3D printing than there is of additive manufacturing when you say those words to people. So as we're trying to educate and drive adoption, we're leaning more so utilizing the term 3D printing because it's easily understood from the get-go, where additive manufacturing, you kind of have to go into the background of what first of all, what are you talking about? Why is it called additive manufacturing, and so on and so on. So utilizing 3D printing as a term has just proven to be a lot easier, and everyone can jump right into the conversation having an understanding, maybe not crystal clear, of a difference between FDM and, let's say, binder jetting, right? But they have an understanding of what the topic of conversation is and how it's different from what they're doing today. So I agree with Barbara on the blurred lines, but we're really focusing on just saying 3D printing because it's more inclusive. Especially bringing in people that haven't had experience with the technology before.
No, I think that those are very valid answers. And again, I think it also depends on how familiar you are and what your experience has been within the industry. So going further into the economics, are there specific technologies in your experience? So you both have very different experiences. One, coming from the conventional side, Barbara, are there financial benefits for additive manufacturing? Sorry, no, I messed that up. Are there specific technologies that provide higher cost savings over others? We'll get to that other question in a minute, but
Absolutely. There's certain technologies that are better suited to certain kinds of parts. And it depends, again, tattooed across my forehead. It just depends on, a lot of times, the part configuration and all those factors I talked about: cosmetic speed, durability, finish, and material selection. All those factors play into the economics of when additive is better. On the early part of product life cycle management, one of the best things is that you reach a good design faster. So you have a fail faster type of set when you're doing your concept development. In your production area, you have parts that are many times associated with the manufacturing that are absolutely a fit for 3D printing. And I'm going to use that term interchangeably with additive because, like you, everyone grasps it really quickly versus additive. They're going, well, are you going to talk about digital manufacturing, all that stuff. So let's use 3D printing. Example are fixturing and work cell check fixtures. Great application. Do they work as the part that you're doing the checking on? Sometimes not. Depends on the volume, depends on the part, depends on the size. It depends on what you want to do with it. So there, again, it depends. It's tattooed across my forehead. The biggest factor, I think, on which is the right technology, the right economics of additive versus traditional manufacturing, is going to be very dependent on the part itself. Nowadays, you can make, with 3D printing, parts that you couldn't make with injection molding. Tooling is a big factor. Besides tooling, you've got mold storage, you have inventory items, you have mold maintenance, you have the cost of materials. Anyone that's sourced steel lately can tell you all about inflationary cost of steel. And I'm sure that you're experiencing that at Black & Decker because it's extremely expensive to get raw materials. Additive can be a great fit in there. It also can be a great fit as a bridge production method. It is going to depend on what you've got in terms of delays. If you look at COVID, are there cheaper products out there now versus 2020? Absolutely. You can get a face shield at pennies on the dollar versus what we all were experiencing when we were scrambling to get face shields and personal protective devices. However, 3D printing really stepped in there when you had to have it quick and you couldn't have any excuses about production delays. So it also is a great fit for bridge tooling. So Circulus references, it depends, but it is a fit. It also depends on the customer definitions of what they consider traditional manufacturing. 3D printing is becoming traditional. Hybridization is becoming traditional. What we may not have yet, though, is the design for additive manufacturing is still evolving, and we haven't hit our limits yet. So it's going to be a new frontier out there a bit, and we still have to educate so many people about what 3D printing is too. So long-winded answer, but it depends.
What about you, Joelle?
Yeah.
Do you identify specific technologies that are higher cost savings than others?
Absolutely. I think Barbara was right on with it depends. I think, for example, laser-based systems, the parts coming off of them are going to be really expensive. So it really doesn't make a lot of sense in, let's say, consumer goods for screwdrivers, for example, to make a laser-based product. So I think just the cost of the equipment really plays a big factor, but ultimately it's what are you looking to gain out of the part? Is it being lightweight? Is it really good product or material specifications? Is it really quick turnaround? So there's a lot of different factors that play into where you're going to see the most cost savings. And then there's also a lot of soft factors that don't necessarily get rolled into the part cost, but just saving on material waste, or like Barbara mentioned, the lead time factor. And during all of these supply chain issues, additive is a really great solution because it's available and you don't have to wait for something to be in front of you from overseas. You can just make it. We've seen that a lot within just the past year. We've been asked to 3D print many things that I don't think were the right fit for additive, but since supply chain issues, we said, why not? Let's take a look at it. Let's see if it's at least around the same cost or less, and can it solve some of our big hurdles with all the supply chain issues going on.
Barbara, you mentioned a little bit about it. Joelle, you kind of touched on it fairly, but what about the man hours? I mean, printing, that's automated, but all the post-processing, even pre-processing that goes in, that's a lot of work. And there's even more work on conventional. Is there a benefit to using one over the others when you look at it from man hours?
It depends. I'm so sorry to keep using that phrase, but in injection molding, for example, you have so many man hours that go into prep, into, you might say, pre-production staging. You have not only design of the part, but you also have tool design, which is significantly different than design of the part. And that's even before you cut steel. You're doing things, you're determining what the tool material will be. There's an old adage in the additive world in that it's called the rule of 10. And I think a lot of us have heard of it. You may have not. I know that Stratus has taught it for a long time. And so it is that whenever you've got a concept and it's on a napkin, if you change the concept, you don't have any cost. But once you put it on a blueprint, you have at least $10. And then whenever you get from the blueprint and you start the approval processes and you start making changes on the fly, so to speak, and this is before you even have it in CAD, you've got $100. Well, then when you put it in CAD, you need to make a design change. Well, I'll put another zero behind that, and you've got at least $10,000 typically when you start to do design changes, and you still haven't cut steel. Once you start cutting steel in production methods, you start exponentially adding cost. The typical mold cost now is you're going to deal with around 3 engineering changes in your molding if you're doing injection molding. Those are prohibitively expensive. The old rule of thumb used to be 5 mold changes, you've got a boat anchor. You really have a tool that's been modified so much that it's compromised. So that is significant cost. But if you go all the way back to design, to find the right design, it's priceless, because worst case scenario, you put a design out on the market that fails and you have a recall. That's an incalculable cost in not only physical product, but prestige and market share. So additive manufacturing, 3D printing, gives you a cost of quality and cost of design assurances that is priceless, because you learn what doesn't work as well as what does. So that rule of 10, it's kind of a general factor in that it's classic project management. When you have a change early on in your project, you have less costs associated with it. The further you are on the project maturation, the higher the cost. If you get done with your project and you have to retrench, retract, redo, the cost is beyond calculation.
Yeah, I think where in manufacturing we look a lot is where we can reduce labor. I think both traditional manufacturing methods and additive have a lot of labor associated with each of them. And our focus right now is where can we reduce touch points where it's really not value added to the end use part. And I think overall, there's a trend within the industry right now to see where can we automate different elements, whether it be putting in a build box or removing supports. There's a lot of technology that's being created right now to support reducing the labor, because ultimately we want to reduce that as much as possible where we can. So I think looking out for those opportunities in both instances of where am I actually creating value for my customer in the end use part, and if I'm not creating value with any touch points, how do I eliminate those? So I think that's something we constantly look into and look at continuous improvement projects and look to limit that in any way possible. So that's something we really focus on.
Are there best practices that you guys have encountered to reduce costs when it comes to additive manufacturing for production specifically?
I think one of the biggest ways to reduce cost is looking at the full downstream processes that have to take place, because there are a lot of great solutions with how you design the part to reduce post-processing or just any other like polishing or anything else that happens to the part. You can reduce significantly through the initial design. So I think something we talk a lot about is taking something that has to be assembled later on and just making it one part from the start. So I think those are kind of a pretty relevant tip of how do we reduce that. Something we've seen also in the industry I'm in is looking at what materials we can utilize. So for example, not needing to polish or plate something after it's produced can save a lot of time and cost just for the product itself. So looking at what's available that currently maybe that material is not being utilized in your industry because of X, Y, and Z. So taking those discovery opportunities to see what else you can use with a new technology like 3D printing.
It's really been impressive when you look at where we are now versus where we were 30 years ago. If you look at what we can accomplish on just plain finishes, wow, it's amazing what the journey has been, especially automation and how much we've automated versus the old day. You know, the Dremel and I are well acquainted with each other on support removal, but now we've got automated post-processing solutions. So looking for that automation, as was said, is a key factor in reducing cost. On 3D printing, any time that you can reduce the number of people that you have to use is usually viewed as a huge cost savings. And the reality is right now in these days of labor shortages, it's hard to find people. So it allows you to not have as many touch points on every project, but more importantly is not look at it as elimination of labor. It's the, you might say, enabling of more projects, because you can put more resources into other areas besides just production. So it allows you to take on more business, and that's a win.
No, and I agree. We recently implemented dimension equipment to our powder bed fusion facility. The automated post-processing equipment is fantastic. It really gives you an end-use part right in your hand within, 24 hours, right? I mean, depends on really the print, but you know what I'm talking about. And you guys mentioned another factor that's very important when it comes to production, which is post-processing. So we've got post-processing as a major factor when it comes to production. You mentioned material, you said cost, man hours. Is there anything else that's a very important factor when it comes to production, taking into account?
In traditional manufacturing, you always have to make sure there's a good fit between your material selection and the part function. And to get true, you might say, equilibrium of what your demands are and of what you can produce, you have to take into consideration what materials are out there. And we've been fortunate in 3D printing recently that there's a lot more materials available than there used to be. You still, however, have a lot of clients that insist on legacy materials and that they're looking at what they're always been used to versus what the material is really doing for them. And in some cases, this goes back to what criteria the part has and what is the part doing. If you want, a good example is clear. We have a lot of demand for clear parts in additive manufacturing through whatever process is used. The question becomes is why do you need it clear? Why do you need color? Why do you need this? And sometimes they don't know. They just know that they want it. So you have to balance what's available versus what you might say the secondary wants and needs. It's almost like an emotional versus logic. Emotionally, I don't care. My car is blue, but I know I want it. So I want a blue car. It's the same thing in parts. It's like, it doesn't have to have, for example, light sandblast finish, but I know I want that. I'm comfortable with it. So sometimes you have to challenge the comfort areas in order to get the true savings as well as the use and the good utilization of the part in whatever media, in whatever format that you have it going. But another factor is just making sure that you go back to understand what the part is actually going to do and what the critical factors are for use. And I think that's something that you have to go back and reemphasize that because each layer of management involved in the decision process may have different criteria for acceptance of the part.
I'd also add for production, one of the biggest elements is quality control and process capability, and ensuring that if you make 100 of the same part, they're all the same. Whereas you can feel pretty confident in that for injection molding, like we've been talking about, but for additive, it's a different ball game. But we still want to be at the same level of confidence that you're going to get the same part 100 times out of the same machine. And I think it takes a lot more for additive manufacturing, a lot more prep work and control planning and initial implementation work to be on the same level as traditional or conventional manufacturing methods. So I would say definitely quality is a huge factor that comes into play of how do you even implement additive into your production environment.
Reproducibility and repeatability is a huge factor in additive. And it's also scale. The scale of production makes a huge difference in your quality assessments.
Yes, and I do want to get into quality. I just want to remind all the participants, you have access to a Q&A if you want to start dropping questions in there and voting them up. We will leave time for some Q&A questions from the participants. But you guys mentioned materials, and we talked about this a little bit early in terms of the product development life cycle. You mentioned legacy materials, Barbara. Materials are a really important part. They really make up the part.
Yep.
Today, in between that blurred line of prototype and production, Is there a clear divide currently between prototype and production materials in your experience?
And this is based on my own personal experience. You don't see very many production parts done in PLA. It's a nice material to use. It's easy to run. It's a great part to use in a prototype setting for form and fit, but functionality is somewhat compromised in a lot of cases on what you're going to do with it, especially if it's going to be exposed to, you might say, a conventional environment. PLA doesn't like moisture, it doesn't like heat. So, however, legacy materials, and those are the legacy materials that we have from injection molding that are so used. We see a lot of ABS, we see a lot of nylon, we see a lot of polycarbonate, but you got to remember within those classifications in the injection molding worlds, there's thousands of different mixes, thousands of different materials. Well, we're not quite there in additive yet. We got a lot more materials than we used to, but we don't have thousands to select from. But when you're dealing with certain applications, they have a legacy call out, especially military contracts, about what material you can use, what you do with it. Some of the testing and qualification of parts are done with legacy materials, and so it's very tough to transfer those certifications over to additive manufacturing. And there's a lot of widespread misunderstanding of certifications. So that's a whole different discussion, different day. But materials are such a vital part of your functionality of your part. You can't underestimate what and when. Just because you know that, example, the customer used Delrin in injection molding for his part, and molding Delrin is no small feat, but he may not need it. He may be very comfortable in an additive part that uses a high heat nylon. So there's a lot of trade-offs that you can do. And sometimes you don't know until you do further analysis whether the part will pass. So material selection in any technology, whether it be traditional injection molding versus additive, is a big part of your part prep. Material availability and what it does inside a mold and injection molding is something that only a skilled tool designer and your manufacturing engineer can really give you some guidance on, especially your flow characteristics. Like you don't want to put a boss in the middle of a high flow area in your part. But in additive, you have certain design rules that are not very well known. And many of them do mix and match from injection molding because it's what you do with the part that makes a difference on your material selection, not the part itself. It's you sell the hole, not the drill that makes the hole. It's what you're doing with the part that makes a difference on what types of materials. There may be call outs for ESD. There may be call outs for any weathering. You've got a lot of what the part itself is going to do for the end user. So material selection is a huge part that needs to be done with an eye on what you think it's going to do in injection molding is going to be different in additive. It's going to change in additive. It's not going to behave the same. Injection molding imparts characteristics to the piece based on the heat and pressure that are used on putting that part into a core and cavity. So you have to keep in mind that what you think may not be true in additive and vice versa. So a lot of times you can get away with different materials in additive than you can in injection molding and vice versa. So material selection should be talked about early on in your product life cycle.
I love this topic because I think it's something that comes up a lot. Especially Stanley Black & Decker has been around for quite some time. So a lot of the times if we're looking at maybe an additive solution, that's one of the first things we ask is, okay, why is something being made with this material? And 9 times out of 10, the person that made that decision is no longer with the company. We don't know why it's being made with that. We don't know if the hardness actually needs to be as high as it's being called out. So that's something we've really worked hard on trying to educate on is, okay, what are comparable materials that exist in the additive industry, and does that satisfy your need? And how do we backtrack and say, what are we actually looking to accomplish, to Barbara's point, as far as what is the end use application and what is the function of it, and can we get there with a new material that we've never even considered before? So I think that's something we live every day. So really educating and providing enough information to say, if this is even a viable solution, should we try it out? Is definitely something we consider when we're looking at if additive is a good solution and is a material available that would apply.
Yep. And now for one of the most important parts, something we haven't really talked about yet, quality. Quality is essential from the beginning. I think we both agree in keeping it in mind. But how do you think industries, companies particularly, are ensuring that their additive manufacturing production is going to keep up with conventional production quality requirements and regulations?
I think heavily regulated industries are really paving the way for how additive is viewed in production environment, because industries like automotive or aerospace, they already have really stringent callouts of what is appropriate, of what the right procedures are to be. So using that as a starting point, where if you're satisfying those callouts, you'll be fine in any other industry utilizing additive. So I think that's where we started, as far as where are we going to look to utilize additive and how are we going to test quality with that, is how do we make it really robust, and then we can work our way back based upon the needs of the application or the industry. But I think really the aerospace and automotive industries have done a really great job defining what quality needs to be. So using that as a starting point is how I think about it.
There's still work being done on a couple of the main factors that we run into in additive, and that's reproducibility of the part across the build bed. That's one of the things that I think almost every manufacturer is dealing with on the machine side, is to make sure you have a reproducible part first time, every time, not only from build to build, but within the build, if you're doing quantities. And so that you want to be able to have linear predictability on what you're going to get out of your machine, whether it be in the front right-hand corner or the back left-hand corner. You want to have predictability, reproducibility, and a confidence that your machine is going to produce the same part each and every single time. And it is a lot better than it used to be. It still needs to be a little bit better across the universal constraints of all equipment, and I've worked with so many of them. The other area that I think is largely, you might say, not as understood as we'd like, is that material itself in the production industries varies tremendously. You have melt indexes that typically have a range. In additive, we have a much smaller range that we typically use versus production methods. So because we have such a smaller melt range, or whatever, a smaller indices on what we're doing with the material, whether it be a thermoplastic, a thermoset, or a metal for that matter, we have additional cost on those materials versus typically production materials, because we have to control the quality of them so much better. So if you go to an open materials platform, for example, you have to recognize that there's oftentimes associated cost with machine setup, both in metals, thermoplastics, and thermosets. So that's what you get. That's a bit of a trade-off in terms of quality control measures on the material side. On the build side, especially if you're using open platform, you may also have some variability that you can dial out of the machine, but you need to be aware that it's not going to run the same time every time from batch to batch of material. That's the same thing true of injection molding. You change one Gaylord out for another Gaylord of the same material, even if it's in the same batch, you're going to have some variability depending on that place in the production area. So quality we always look for the zero variability in the quality. We always want to use the Deming method where we have a really dialed in process and we have zero variability. We're still getting there. We're not there yet, but we're still getting there as an industry, both in production methods such as injection molding and in additive manufacturing. So variability affects by material, processing conditions, as well as equipment used, as well as the conditions that the part is going to be subject to.
Perfect. So we're almost out of time. I think we got, I don't know how long we have. Lindsay can haul that out. But we do have 3 questions in the Q&A. Joelle, Barbara, you guys should be able to access that. The first one is, where do you think design tools come into play as you are designing for different industry needs?
My first thought with that question is, the different CAD softwares that are available. And I think utilizing whichever software fits for that industry is going to be critical for adoption into the different businesses that are trying to drive additive manufacturing as a solution, because you don't want to be utilizing a software that, first of all, no one knows or they're uncomfortable with, because you're trying to make additive as agreeable of a solution as possible when someone's never used it. I think there's a lot of opportunity to break into that space of software to make it as easy as possible. And especially going back to what we were talking about before about labor, there's an immense amount of labor necessary to create CAD models, and that's not necessarily a skill that everyone has, and it's very time consuming. So having a software that would automate more of the design process and designing for different industries, I think would be something really great to see in the future, to drive that adoption further.
Which also dovetails into the second question, which is interesting. I'll go into the second question in here. What are the most used automated solutions for AM? And what areas of AM process are most valuable for automation? I'd say 100% of the process, but that's impossible.
Yeah. I have a lot of experience in what we call mass finishing. So in the jewelry world, as you can imagine, you want your part to be sparkly and smooth. So something that we talk about a lot is, how do you finish the part without ever having to touch it? And there's a lot of automation solutions that are already available and have already existed for many years. So understanding those technologies and utilizing them for the different additive solutions out there is something that we look into a lot.
And ironically, is the one with the most man hours, oftentimes, not all times.
Mm-hmm. Yeah, doing that automation on the post-build processing. And I note there's a difference between post-finishing and post-build processing. Support removal. If you can automate support removal, you typically cut a tremendous amount of time off your additive. If you don't have any support removal process, it's extremely time and precision oriented. And then the post-build finishing, the finishing of it. Just like if you polish an injection molding tool, it takes a lot of time. But if you polish a part that's going to be used for whatever reason that you're doing polishing, or you're doing coating, or you're doing some other type of post-build finishing, it's usually manual, and it usually takes a lot of time, and it usually adds a tremendous amount of cost. So yeah, I totally agree with you. Post-build is where the automation really can help. I do hope that I know that many of our audience in the Women in 3D Print world also run into inventors. And one of the things, a central question is, make sure that they have a CAD file. But if you don't have a CAD file, make sure you charge them to make one because that's a real expensive process. So they don't have a file that you can print, garbage in, garbage out, or they don't have a file. it would be nice to have a file that can go directly into your machine. But if you have to create it, it takes a lot of time. So if you have a customer that wants you to quote something, make sure that they have a file that you can actually quote from.
And thank you, Barbara, for that. These are all great points. We have one last question. Barbara, this one's specifically for you. Do you think material characterization is important, and does that help before getting too far into production? I think I know your answer, but I'll let you.
Well, I think material characterization is important. The question is, how much do you want to devote to doing that? And that you can dial in the materials forever, but you have general classifications of material that are probably most appropriate for a certain type of application. So before you get too far into the weeds, you make your material section and you go up. If you have factors that affect which material that you're going, in other words, if you need to have a filled material so that you have less deflection, you're going to know that up front pretty much. You're going to know that before you go into production in most cases. But you don't want to find out after you go into production that your part flexes too much because you had design that didn't get done. So material characterization dovetails with your design. And that helps before you get into production, because otherwise you have to redesign the tool, you have to redesign it for different materials. You can't run, for example, a syringe out of a mold. You can't run it out of polypropylene if the mold was done, a cylinder was done in, example, in polycarbonate. It just doesn't work very well because you don't have the same material flow, you don't have the same material characterization, you don't have the same release and shrinkage. So it helps. It is not the only thing you have to do, but you have to know your material character that affects the part before you go into production, else you're going to have to go back and redesign your tooling. As well, in additive, many times you'll have to adjust your build patterns in your additive if you're doing FDM type building, or if you're doing a laser-based method, you have to look at where you have cross sections that are good. So there's a lot of design factors and application factors that you have to get into.
So much. Joelle, anything else to add?
I don't think so. I would like to add, the Stanley Black & Decker team is definitely going to be hiring this year. So if you're interested in any of our open positions, please message me on LinkedIn.
And I believe we will be around for the networking session that follows. So thank you, Barbara. Thank you, Joelle, so much for participating in this panel. Really appreciate it.
Thank you.
Pleasure to be here. What a nice team, a nice group of people to be a part of. And thanks to everyone that attended. It's awesome.